Hi, everybody. Welcome to lesson 22, getting the job done with speed, work, and measurement units. So we're going to go ahead and get right into this. This is the same learning targets that you had at the beginning of lesson 21 and will carry you through till lesson 23. In this lesson, if an object is moving at a constant rate of speed for a certain amount of time, it is possible to find how far the object went by multiplying the rate and the time. In mathematical language, we say distance equals rate times the time. Remember that little dot in between is another way to write multiplication. On your paper, where it says, "What is the formula?" I want you to copy the formula D equals R times T, which means distance equals rate times the time. If you need to pause, please do so. Part 1. Chris Johnson ran the 40-yard dash in 4.24 seconds. What is his rate of speed? Round any answer to the nearest hundredth. Well, I just got done telling you that distance equals the rate times the time. But this time, I don't want to know the distance. I already know the distance. He ran 40 yards. So if I were to plug this in where it belongs, 40 is the distance. So 40 is the D in 4.24 seconds. I know that that represents the time. So I don't know what the rate is. So that means that R times 4.24 is going to give us his rate of speed. So that means some number times 4.24 equals 40. And the way we find that out is by dividing. This is just exactly what we've been doing with unit rates. We've been taking the 40 divided by 4.24. I wanted you to see it in terms of this formula of distance equaling rate times the time, so you can see that you can rearrange things in order to calculate whatever part of the problem is missing for you. So on your paper, you're going to set up that 40 over 4.24, which means we're dividing. When you do that division, you're going to see that you get 9.4339622, la 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 la. It keeps going, and we don't want that to keep going. It says round to the nearest hundredth. So if it says 9.433, I know that that first three is the hundredths place. I'm going to look at the second three. So I'll do it over here, 9.433. This 3 is going to tell this 3 what to do. If it's 5 or above, we give it a shove. If it's 4 or less, we let it rest. So since it's less than 4, we're not going to do anything. So this means it is 9.43. Now this time was yards. Whoops. Eek. Per second. That is his unit rate or his rate of speed, 9.43 yards per second. All right, moving on to part 2. In lesson 21, we converted units of measure using unit rates. If the runner were able to run at a constant rate, how many yards would he run in an hour? So we can break this down into 2 steps. Part A, how many yards would he run in 1 minute? Then part B, how many yards would he run in 1 hour? Well, we know from the calculation before that he ran 9.43 yards per second. And since I know that there are 60 seconds in 1 minute, I'm going to multiply that times 60. I'm just going to bring that 0 off to the side there, pretend it's not there, makes life easier. 6 times 3 is 18. carry that 1. 6 times 4 is 24, plus 1 is 25, and carry the 2. 9 times 6 is 54, plus 2 is 56. Now I have 1, 2 decimal places, so I'm going to go 1, 2 decimal places here. So that means 565.80 yards he would run in 1 minute. Okay, so I have put his 565.80 yards in a minute right up there. But now I need to find out how many he can run in an hour. Well, again, I know that there's 60 minutes in 1 hour. So if this is what he can do in 1 minute, if I want to know what he can do in 60 minutes, I'm going to, again, multiply this times 60. Now, you guys have a calculator. I'd like you to pause and calculate what you would have when you multiply 565.80 times 60. Once you do that, you should see that you have 33, 948, which means that's how many yards he can run in 1 hour. 33,948 yards in 1 hour. So really, we did that in 2 separate problems, but this frame here shows us how we can do it in 1 step. So we took our initial yards per second, which was 9.43. We then multiplied that times 60. Got that answer, then multiply that times 60, got that answer to come up with our 33,948 yards in 1 hour. I'm going to take that another step further and find out how many miles the runner traveled in that hour. We're going to round to the nearest tenth. So we're going to take my 33,962 yards per second. Yards per hour. Yards per 1 hour. And I'm going to figure out how many miles that is. Well, I know that there are. So since there are 1,760 yards in 1 mile, I need to take my total yards that I have, which is 33,962, divided by 1,760. So if I divide by 1,760, I know that I'm going to get 19.296. The problem says round to the nearest tenth, so I'm going to take a look at the hundredths place. And what is that 9 telling the 3 to do? It's telling it to go. I'm sorry, what's the 9 telling the 2 to do? It's telling it to go to a 3. Look at that, I get ahead of myself. Okay, so that means that he ran 19.3 miles in 1 hour. Okay, moving on to exercise 1. I drove my car on cruise control at 65 miles per hour for 3 hours without stopping. How far did I go? So we know that the unit rate is 65, go back to my pen, 65 miles per hour. I did that for 3 hours, which means in the first hour I went 65, the second hour I went 65, the third hour I went 65. So if I'm looking at my formula of distance is the rate times the time, the distance that I went equals the rate, which we know the rate this time, 65 miles per hour. The dot represents times. So if you want to put an X in there, I know that doesn't look like an X. Instead, you could do that for 3 hours. So I'm going to multiply that times the time. 65, and you have plenty of space on your paper to be able to write this down. And I do not think we need a calculator for it. 5 times 3 is 15. carry that 1. 6 times 3 is 18 plus 1 is 19. So 195 is the total miles. So 195 total miles. On the road trip, the speed limit changed to 50 miles per hour in a construction zone. Traffic moved along at a constant rate of 50 miles per hour, and it took me 15 minutes or 0.25 hours to get through the zone. What was the distance of the construction zone? So, before I even get into this, I want to talk about this conversion of minutes to hours. Pretend this is a clock. Here's your 12 o'clock, your 3 o'clock, your 6 o'clock, your 9 o'clock. And as you know, that just broke it up into quarters. We know that since the clock or the hour is 60 minutes, half hour is 30 minutes, which means a quarter hour is 15 minutes. So that's where that conversion of 15 minutes to 0.25 hours comes. So we can still follow our formula, but I wanted you to see that in a model form. So our distance is our rate times our time. We know the rate is 50 miles per hour. And we know the time is 0.25 hours. I did not use the minutes. I went with the 0.25 hours because that's what the label is indicating. Plus, we want to keep that consistent with what we had over here. So 0.25. If you type that in your calculator, you know that 50 times 0.25 is 12.5, which means the distance of the construction zone is 12.5 miles. So now you've seen a couple different examples where we've had to do some conversions in order to use our formula distance equals the rate times the time. There is nothing different than what we've been doing with unit rates. You're just starting to learn a little bit of a layer on what a formula could be to represent each thing. So D is our distance, R is our rate, T is our time. You just have to identify what belongs where in order to calculate your answers. Your turn now to go finish your problem set, lesson 22 in Google Classroom. It is a must do activity. You may use your whiteboard, you may use scrap paper, you may use a calculator. The only thing is, I want to be able to identify that you didn't just write an answer down. So, yet, even though you don't have to show me the division, I want you to write down that you did divide. So, in this case, or if you had a problem that was like our first one with 40 divided by 4.24, I want to see 40 divided by 2.24 equals your answer. That way I know you did the division. Work independently so that you can get your marbles at the end.